Hey guys, what's up? Welcome back to another video. So today in this video I'll be teaching you about projectile motion and covering all the aspects of it in A-level physics so that I can make it as clear for you guys as possible. So projectile motion, what is exactly projectile motion? Projectile motion is motion in two dimensions. So in two dimensions, and it is motion it is motion in which the body is traveling both horizontally and vertically. An example includes kicking of a football. For example, this is a football over here, right? And this is a person standing over here, and he kicks the football, and the football will travel up and then it will come down. So the path that the football is following, it's called the projectile's trajectory. Projectile's trajectory, right? So when a football is kicked from here, it is following this path, which is called the projectile trajectory, which I've shown through the black dotted line, right? So at the start of the motion, the body is at point A, right, where the actual velocity is tangent to the projectile trajectory. So the velocity of the ball, at point A, is tangent to the curve, projectile's trajectory, right? So over here, this is tangent, so this is called the actual slash true velocity. So the true velocity is always tangent to the projectile's trajectory. For example, if the football was over here, what would its true velocity be? So it will be tangent to the projectile's trajectory. So something like this. So for example, this was the ball, the ball was here, so something like this. It is always tangent to the projectile's trajectory. What will be the actual or true velocity over here? It will be tangent, a horizontal line. What will be the actual or true velocity here? It will be a tangent like this, right? So the actual true velocity can be resolved into two components, horizontal and vertical. So first we have seen that the actual or true velocity is always tangent, and now we are saying that the actual or true velocity can be resolved into two components. The two components include the horizontal component and the vertical component. I have represented the horizontal component as VH and the vertical component as VV. VH means horizontal component of velocity, of actual velocity or true velocity, and this is the vertical component of actual or true velocity, right? And in some books it is also written as Vx and this as Vy, right? Now let's move. Okay, so the horizontal remains same. So the horizontal component remains same throughout the actual velocity. But before telling you that we need to first understand what VH can be written as and what VV can be written as. So VH can be written as V cos theta and VV can be written as V sin theta. And the horizontal component, which is VH, it remains same throughout the projectile's trajectory. So same. So if you found VH over here or here or here, it will be same throughout the projectile's trajectory, right? And the vertical component changes. The acceleration throughout the projectile's motion, I'm talking about the vertical acceleration, remains negative. Horizontally, acceleration is 0. Why is acceleration 0? Because speed is constant, and when speed or velocity is constant, acceleration will be 0, right? And only horizontal component remains. So, and at the topmost point, which is point B, the vertical component of velocity becomes 0. I'm talking about this point B, and only horizontal component remains. As you can see here, there is no vertical component and only horizontal component remains. This is the topmost point, right? Projectile motion is a symmetric motion. So the time taken for the ball to reach from here to here, time t seconds, it will be same as the time to reach from here to here. So from here to here, the time taken from here to here will be the same as time taken from here to here. So if this is t, this will be 2t, right? In order to find vertical component of velocity after t seconds, in order to find horizontal component of velocity after t seconds, as you know, horizontal component remains same. So after any time, for example, if they say find horizontal component after 10 seconds, after 10 seconds, right? So it will be the same as it was at 1, as 2, as 3, as 4, as 5, as 6, as 7, as 8, as 9. So for example, if you found out that the horizontal component was 10 meters per second, so it will be the same after 10 seconds, after 20 seconds, after 30 seconds, it will always remain 10. But the vertical component will change. So we'll find that through v is equals to v sine theta minus gt. So how did we get this? So as you know, v is equals to u plus at, and as you know that initial velocity was v sine theta, plus acceleration was negative g, which is negative 9.81, and time taken was t seconds. Hence we got the vertical component of velocity after t seconds to be v sine theta minus gt, and horizontal component after t seconds will always remain same, which is v cos theta. And in order to find displacement after t seconds, so let me write it again. After t seconds, we can break the displacement into two parts: horizontal displacement and vertical displacement. Since speed remains same, so we can apply velocity is displacement upon time. Velocity is same, so vh into t is equals to sh. So horizontal displacement is equals to horizontal component into time. Vertical displacement, the vertical displacement is s is equals to ut plus half at square. Okay, so an initial velocity is v sine theta, time taken is t, plus half acceleration, as you know, throughout the projectile is negative, and t square. So v sine theta into t minus half gt square, that is the vertical displacement after t seconds. You just need to plug in the values. And then in half trajectory, what does it actually mean? For example, you have this tabletop over here, right? For example, whatever kind of table this is, right? And here you have a ball. So first you're gonna give this ball a push, right? You're gonna give this ball a push, and it will start moving horizontally. And after from here, from the tip over here, it's gonna fall and to the ground over here, right? So initially it travels horizontally, and then this. So this is half trajectory, because this is not the whole of projectile motion. Whole of projectile motion looks something like this. The ball was here and then it reached here, but over here the ball is initially traveling horizontally and then it reaches here, right? So it is when a ball moves horizontally initially, its initial speed is the horizontal component of projectile motion. The acceleration remains positive, right? So it initially in the half trajectory, the ball initially moves horizontally and then follows a half trajectory. So and it is when a ball moves horizontally initially, its initial speed is the horizontal component of projectile motion, which means that whatever its initial speed, for example 12 meters per second, it will be the horizontal component of velocity will remain same. For example, if the initial speed was 12 meters per second, then over here the horizontal component will be 12, 12, 12 and 12, right? And the acceleration in half trajectory remains positive. In full trajectory, which means throughout the projectile, it remains negative, but in half trajectory, this is an exception where acceleration will be positive. I've covered all of the components of projectile here. Just a few things that you need to remember is that, for example, you are giving these three, and you need to relate VV, VH and V. So you'll simply apply Pythagoras theorem, which is hypotenuse square is equals to base square plus perpendicular square, right? So these relate all three components of velocity, right? And in order to relate angle and both the components of velocity, which is angle and both the components of velocity, you'll use tan theta is equals to opposite over adjacent, right? And for maximum, sometimes the examiner asks for maximum kinetic energy. So maximum kinetic energy will be over here at point A and at point C, right? So maximum kinetic energy is at point A and point C, right? And maximum gravitational potential energy is at point B, because it is at the highest point above the ground. So highest gravitational potential energy, so let me write it over here. Highest gravitational potential energy, and over here highest kinetic energy, like over here which highest kinetic energy. So in the last I have concluded that in order to relate all three of the velocities, we'll apply Pythagoras theorem. In order to relate theta with the two velocities, we'll apply tan theta. And for highest gravitational potential energy, it will be point B, and for highest kinetic energy, it will be point A and point C. So that's it for projectile motion. Thank you guys for watching. Take care.